and welcome to the session. In this session, we will be describing about the basic von Neumann architecture component backing storage device. The von Neumann architecture never defines backing storage device as one of its components. However, if we would like to fit this into the von Neumann architecture component, it cannot fit into the processor component, neither can it fit into the component of the memory. Although we have defined the storage devices or storage technologies as the one part of the memory system, however, if we want to fit this particular thing into von Neumann architecture category, then automatically the storage technologies and storage devices fits into the input-output device category. Our basic objective in this session is not to define various input-output devices which you can experience by yourself, but the storage devices which according to us are immensely important. Reason being, you know, the technology which processor and memory supports are mainly electronic in nature. That simply means you need something which can preserve your data, your programs for the period you want them to be available. I mean, you want those kinds of information to be available even later on, whereas the processor and the memory technology, which are volatile in nature, loses the content as the power is switched off. But you want your program, even if the processor is switched off, should be available somewhere. Therefore, the storage technology has a major role to play in the operation of a computer system. Even operating system, which is one of the major program of your computer system, which is responsible for the major functioning of the computer system, is stored in the disk or one of the storage devices. Therefore, this is one of the major component of any computer system, and we would like to describe some of the basic formats about them. We would also like to describe how a storage device can be linked to the computer processor. We would like to describe one of the major, in fact, you would like to know what kind of different storage technologies and storage devices are available. Well, basically you can categorize all the storage devices which are available into two broad categories, one happening to be the magnetic category, the second happening to be the optical category. We will start our description about the magnetic category. Now, in that particular category, the very first question which arises is, we have heard about the term called magnetic disk very often, but what is it? After all, it's a storage device, but I would like to know more detail about it. A magnetic disk is a circular or plastic disk which is coated with the magnetizable material. The basic objective of that magnetizable material is to store zeros or ones, which are the basic digits of computer system, in a sense storing the basic information about a computer. The second thing about magnetic disk is that it supports a mechanism using conducting coil, which we say read-write or mechanism, and this particular mechanism is supported by something which we call head, which is responsible for reading the information or writing the information onto the magnetic disk. The third most important thing which goes with the magnetic disk happens to be the basic format which it supports. It basically supports concentric tracks with width same as that of head size. What does it mean? What do we mean by saying that magnetic disk supports concentric tracks of which would basically support some kind of read-write mechanisms and so on and so forth? Well, we would like to look into the figure for that. If there are, you can find in this particular figure that there are some black portions, okay, and there are certain white portions available. The black portions are basically defining an area which is separating the read-write area onto the disk. Now the whole circular stuff, that is, you can see onto the outer periphery which I am rotating my mouse on, this particular thing is a circle, it's a complete circle. This is called a track onto a magnetic disk. The gap which I was showing to you, this is called inter-track gap. After all, it exists between two gaps. What is the need of this? We would like to define that also. Meanwhile, you will find there are small segments in each track. These are called sectors. You will find this is another sector, this is another sector onto your disk. And there is definitely a gap in between these two sectors. So this is the basic disk layout which exists in any magnetic disk. But we would like to define why these particular things are needed. In that particular category, the very first question comes to my mind is, why does gap exist between the adjacent tracks? What is the need of that particular gap? Obviously, the reason turns out to be, disk is a mechanical media. After all, it rotates onto a spindle, and that spindle is rotated by some mechanical mechanisms. Under these circumstances, there are possibility of errors because of slight misalignment of those spindles. Those errors can be minimized if there are gaps existing between two tracks. In addition, the other objective over here is to minimize interference of various magnetic fields. After all, reading and writing on a disk is through the conducting coil which is head, and that is the magnetic conducting coil. In any case, if the tracks are very close to each other, the chances of that one particular pixel or dot of information interfacing or interacting or causing interference into the reading of second dot or magnetic spot, that will lead to lot many problems of reading and writing and lot many errors while reading and writing of data. Therefore, for avoiding all these things, we always keep an inter-track or between the two tracks, we keep some gap. One more thing which we would like to highlight at this point of time about the track, that as you have seen in the diagram, the outermost track happens to be the largest. After all, it is a circle. So innermost track happens to be the smallest, whereas the outermost track happens to be the largest. What does it mean? Is there any significance of this particular fact? Well, yes. What you are going to find that the innermost track controls the density of information which can be packed into the disk. That is, the density, the information which you can pack into a disk is determined by the capacity of innermost track and not the outermost track. But then why do we keep this kind of a mechanism? What is the need that innermost track is keeping the same amount of information which outermost track is keeping, in return wasting lot of disk space? Well, if you try to work out this particular mechanism, think of a mechanism that I have divided my disk into equal number of tracks. Now if I rotate the disk at the same rotational speed, then the outermost track will move more distance than the innermost track as it is moving the largest distance. Therefore, if I want to simplify the electronics, and that was one of the reasons which we want to put into the magnetic disk, that is, the storage, the rotation speed does not change, okay, and that causes our tracks to be of same size, and the same size in the sense, same storage capacity and not the same density. So keeping that particular objective, that is to simplify the electronics, we always tend to keep similar storage capacity in all the tracks of the magnetic disk. Another feature which I would like to define here is that the data which are stored in the block size region, okay, which we call sectors, okay, are identical across the disk. In a track, same number of sectors does exist, and typically you will find a disk consists of 10 to 100 different sectors which are there. In addition, what you are going to find that there are some precision requirement, where a sector is starting, where a sector is ending. All these things are to be identified, okay? But before we can identify, or before we can go to that particular thing, the first thing is, what should be the size of the sector? In general, what you are going to find that a sector is of 512 KB in normal disk. It may go up to 1 kilobyte and so on and so forth. But what size of data is stored in each sector, that is to be identified in each hard disk. What are the basic requirements? The basic requirements happens to be the gap need to exist between two sectors. But if the gap does exist, how the hard disk knows, or how the read-write mechanism knows that there exists a new sector? Okay. Well, for those reasons, we need to look into the control data, which is recorded at the start and end of each sector of the hard disk. The example which is normally given in this particular category happens to be, normally you know that 512 KB is the size of your sector, yet you will find in general for that sector in a disk you record 600 KB of information, which is much more than what is the size of your sector is, or the logical sector, that is 512 KB of information is. The reason mainly is required, why this particular additional information is required, mainly for three basic reasons. First, to identify a sector. Second, for the error correction and checking bits. And third, definitely to store the data. There are some additional characteristics which goes with any hard disk, or in fact, let's not call it a hard disk, let's call it a magnetic disk. The basic mechanisms which goes with the disk happen to be the head motion. There may be certain disks in which the head need to be moved from one track to different track. What those kinds of disks are called? The movable head. Why? Because you are moving the disk, you are moving the head into that particular disk. Why do you need to move the head? The basic reason, once again, in that particular category falls down to, since you have only one head, therefore in that particular platter or surface, therefore you need to move the particular head into the surface from the innermost to the outermost, or wherever in between you want to be. The other kind of mechanism which exists over here is the fixed head mechanism. In that particular category, for each track we need to have one read-write head mechanisms. The second characteristic happens to be the portability of disk. You are going to find that there are disks which are portable, which we normally term as floppy disk, and one such floppy disk is existing or is in my hand. This is a portable disk. I can take it to anywhere I like. I store my data onto it and carry this particular disk. The second disk, which is normally not portable, is called Winchester or hard disk, which is mounted into your computer. Although that can also be portable, it can be taken out and can be mounted into a different computer. But for our sake, we can call it that this is a disk which is mounted in my computer and cannot be taken out. It is not that portable as my floppy disk is. The basic advantage of portability happens to be, the portability gives me infinite storage space. Although the storage space for a disk may be limited, yet you can, since you can change the floppies, you can change the number of disks, you can take use of many disks, therefore the capacity is infinite, whereas the mountable disk have a limited capacity. The next two characteristics which are there happens to be sides and platter. Well, sides basically and platter are related. A platter is basically in a disk which I have shown you, the floppy disk, there is just one platter, and both the surfaces are used for recording the information. Whereas in the case of Winchester or hard disk, what you are going to find, that data may be recorded into several platters. There are several surfaces existing. On each platter there may be two surfaces. Platters may be 2 or 3 different platters, just 3 different disks stored into a stack. That is how you can understand that particular organization. One of the most important characteristics which we must know about a disk happens to be the head mechanisms of a disk. What do we mean by head mechanism? We mean by head mechanism is the read-write mechanism which is supported by any disk. There are 3 basic types of read-write or head mechanisms which exist on a disk. They are the contact, fixed gap and aerodynamic gap. In the contact we have pointed out floppy disk is an example. What do we mean by contact head mechanism? Well, in these head mechanisms, the surface of a disk, which is magnetic surface, is in contact with the head. The basic advantage of that particular thing is that it is very close and it can do some sort of error-free reading and writing. But the disadvantage of this particular mechanism happens to be, since the head is rubbing against the magnetic surface, so the chances of erosion, the chances of that your disk will be corrupted after over a repeated use over the period of time are much more higher. And that is why you will find normally the life of a floppy disk is categorized to be somewhere 1 year or maximum 1.5 years to 2 years. Otherwise it loses. You will find if you keep on using that particular floppy, it keeps on developing something called bad sectors, which because of contact mechanisms get developed. The second mechanism in this particular category happens to be fixed gap. The gap between the head and the disk is fixed, but there are basic disadvantages of this particular mechanism. In case of misalignment of disk, this particular mechanism may fail, because this particular mechanism basically rely on very, very precise mechanical motions. The gap between the head as well as the disk surface basically controls the density also, because the closer you are to the surface, the closer you can put the dots or pieces of information which are to be recorded onto the disk. Therefore, this particular, in the fixed head mechanism, if the head is or the distance is fixed, then it controls even the read-write, how many information and all that. And in case there is some problem with the disk, that is some misalignment problem, then automatically this kind of a disk is going to give you lot many errors and immediate errors, which are not because of magnetic read or write, yet because of misalignment. Definitely erosion of the disk in these kinds of cases will be much, much less. What people did, the designers and the computer people, as you know, they are very nice people, very intelligent people, and they designed something which is in between of the two and very, very efficient, which controls or which have the advantages of the both. And that particular mechanism is called aerodynamic gap mechanism, which is existing in your Winchester disk or the hard disk which you use into your computer system. In this particular mechanism, basically the head which is a conducting coil, in a rest position rests onto the surface of the disk. And as the disk starts, it rotates at a rotation speed of almost 3000 RPM. Now that rotation speed is sufficient to create an aerodynamic pressure which causes the aluminium kind of foil kind of a disk head, which is not made of aluminium, but it can be compared to some sort of aluminium foil kind of a head, which is resting onto the disk, and as the disk is rotating, the aerodynamic pressure lifts the head above the surface of the disk. Now that is aerodynamic gap is created, and that aerodynamic gap is sufficient enough. It's controlled by the mechanism of the rotation, therefore the problem of that it is basically very close to the fixed head into that particular category, since the head is not touching the surface, and it is very close to the surface since the aerodynamic gap can be very, very minimal. Therefore, this particular mechanism supports very large storage as well as doesn't erode the surface also. And that is why you will find that today's hard disk are cased into a very small encasing, maybe of the size of 2 to 3 floppy disk casing. Okay, so this is what is the basic thing. But what do we experience? This Winchester disk technologies are very good. They are very useful in a standalone home computer. But as the technology is growing, as the requirement of the technology is growing, you cannot compromise even in this kind of error rate. A hard disk support a very low error rate, but even those error rates are not compromisable in the current situations. So what do? Can this technology be supplemented with something which can be utilized in a very good fault-tolerant kind of environment? Well, yes, those kinds of technologies are existing in magnetic disks, and those technologies are called RAID technologies. The RAID basically stands for Redundant Array of Independent Disks. What do we mean by redundant array? Obviously, we mean there will be more than one disks which will be stacked together, and there will be redundant information available on those disks, and they will be operating under the same control mechanism, and they will be operating as single disk rather than multiplicity of disks. The RAID supports multiple disks, but they will be operating under the one disk environment only, and we will call it just one disk, although there will be redundancy of information which will be available on this particular disk. There are 3 basic features of RAID technology. These are a set of physical disk drive viewed as a single logical drive, which I have already explained to you. Data is distributed across the physical disk drives as an array. Basically, you have redundancy of information. What do I mean by redundancy of information? Same information may be duplicated in some form. We are not defining that particular form because this is beyond the purview of this particular BIT program even. Maybe in the next trimester we will be going for that. But data is distributed among these various disks with the objective that in case one portion fails, then the data can be made available from the second portion, thus making available to us a very good technology which may not fail under the given circumstances, maybe any given circumstances. There are several levels defined for this RAID technology, and some of those does not fail, in the sense they may fail, but they may give some precondition, pre-warnings for those kinds of things. The last point which I have given is redundant disk capacity is used to guarantee data recoverability in case of a disk failure. Once again, since I have already explained to you, but let me explain it again. Since we are making information, redundant information available at several disks, therefore, whenever the data is lost, suppose data is lost on one of those arrays of disks, it is made available from the other array. In addition, it can also be utilized in increasing the capacity, in fact the transfer of information to the disk. So this is in general what we say RAID technology, and these two basically, that is the magnetic disk and the RAID, comes under the magnetic disk technologies. One additional point about the RAID technology, it supports the recoverability even if one of those disks which is available as a stack of disks may fail. That is, redundant disk capacity is used to guarantee this data recoverability in case of a disk failure. What does it mean? Basically, you will find in certain situations, as the data is redundantly available on several disks, suppose one of those data disk malfunctions, misbehaves, then data can be made available from the other disk. In addition, the same technology, as it consists of more than one disk, therefore it can be utilized for increasing the data transfer rate from to the magnetic disk to the main memory of to the main computer, and that basically increases the capacity, the transfer capacity of any magnetic disk, and this is a very important advantage for RAID technology.